Question 1. Implementation of a remote pilot's self-assessment of their physical condition prior to a routine commercial drone operation, when experiencing a temporary, mild but noticeable visual disturbance due to allergies. What is the most compliant and safest course of action? Option A. Operate the drone at a lower altitude to compensate for any potential visual impairment. Option B. Immediately cease pre-flight checks and report the condition to the operator or relevant authority, requesting guidance on fitness to fly. Option C. Conduct the flight but avoid complex maneuvers and stay within a very confined operational area. Option D. Proceed with the flight, assuming the mild disturbance will not significantly impact the ability to maintain visual line of sight. Correct answer is B. Immediately cease pre-flight checks and report the condition to the operator or relevant authority, requesting guidance on fitness to fly. Explanation. This scenario presents a professional challenge because it requires a remote pilot to balance operational requirements with strict adherence to regulatory mandates concerning personal physical condition. The pilot must make a judgment call that directly impacts flight safety and legal compliance. The challenge lies in accurately assessing whether a temporary condition significantly impairs vision or hearing to the point of posing a risk, without overreacting or underestimating the potential danger. The correct approach involves the remote pilot proactively and accurately reporting any condition that might affect their ability to safely operate the aircraft. This aligns with the fundamental regulatory principle that pilots must be medically fit to fly, specifically under the FAA's regulations for remote pilots, Part 107. Pilots are required to be in a physical and mental condition that allows them to safely operate a small unmanned aircraft system. While Part 107 does not mandate a specific medical certificate like Part 61, it implicitly requires pilots to self-assess and ensure they are not impaired. Reporting a condition that could affect vision or hearing, even if temporary, demonstrates a commitment to safety and regulatory compliance. This proactive reporting allows the FAA or the operator to determine if the pilot is fit to fly or if a temporary restriction is necessary, thereby upholding the highest safety standards. An incorrect approach would be to operate the drone despite experiencing noticeable visual disturbances. This directly violates the implicit requirement of being in a condition to safely operate the aircraft. The FAA's regulations are designed to prevent any impairment that could compromise the pilot's ability to see and react to their surroundings, maintain visual line of sight, VLOS, and avoid hazards. Operating with impaired vision, even if temporary, creates an unacceptable risk of collision or loss of control. Another incorrect approach would be to assume that a temporary condition will resolve itself before the flight and therefore not report it. This is a failure of professional responsibility and regulatory compliance. The pilot has a duty to ensure their fitness to fly at the time of operation. Relying on a future resolution is speculative and bypasses the necessary safety checks and potential regulatory guidance. Finally, an incorrect approach would be to downplay the severity of the visual disturbance to oneself or others. This is a dangerous form of self-deception and a direct contravention of the safety culture promoted by aviation regulations. The pilot's perception of their own fitness must be objective and grounded in the potential risks to the operation and the public. The professional decision-making process for similar situations should involve a clear self-assessment of physical condition against the demands of remote piloting. If any doubt exists regarding vision or hearing capabilities, the pilot should err on the side of caution. This means consulting the relevant regulations, e.g., FAA Part 107, assessing the specific operational requirements, e.g., VLOS, weather conditions, airspace complexity, and if any impairment is suspected, reporting it to the appropriate authority or supervisor before commencing flight operations. Transparency and a commitment to safety above all else are paramount. Question 2. Which approach would be most appropriate for a remote pilot to ensure compliance with pre-flight planning and procedures before conducting a routine commercial drone operation in controlled airspace? Option A. Conduct a comprehensive review of all available weather data, airspace authorizations, NOTAM, and aircraft logs, cross-referencing them with the planned flight path and operational limitations, and delay the flight if any discrepancies or safety concerns arise. Option B. Briefly review the general weather conditions and airspace status, assuming no significant changes since the last operation, and proceed if the aircraft appears to be in good working order. Option C. Proceed with the flight as planned if the intended flight time is short and the pilot has prior experience in the operational area, making a quick visual inspection of the drone. Option D. Rely primarily on the drone's onboard pre-flight diagnostic system to confirm operational readiness, and assume that any necessary airspace authorizations have been automatically handled. The correct answer is A. Conduct a comprehensive review of all available weather data, airspace authorizations, NOTAM and aircraft logs, cross-referencing them with the planned flight path and operational limitations, and delay the flight if any discrepancies or safety concerns arise. Explanation. This scenario is professionally challenging because it requires a remote pilot to balance operational efficiency with paramount safety obligations, particularly when faced with potentially conflicting information or time constraints. The pilot must exercise sound judgment to ensure all pre-flight planning requirements are met without compromising the integrity of the operation or the safety of persons or property on the ground. Careful consideration of regulatory mandates and operational best practices is essential. The correct approach involves a systematic and thorough review of all relevant pre-flight information, including weather forecasts, airspace restrictions, NOTAM, and the intended flight path, cross-reference with the aircraft's operational limitations and the remote pilot's own proficiency. This comprehensive verification ensures that the flight can be conducted safely and in compliance with all applicable regulations. Specifically, adherence to regulations like 14 CFR Part 107, or equivalent for the specified jurisdiction, mandates that a remote pilot in command must conduct a pre-flight inspection of the unmanned aircraft, and that the pilot must be aware of the operating conditions, including weather and airspace. This approach prioritizes safety and regulatory compliance above all else, reflecting the ethical responsibility of the remote pilot. An incorrect approach that prioritizes speed over thoroughness, such as quickly glancing at weather without verifying its current relevance or potential changes, fails to meet the regulatory requirement for due diligence. This could lead to operating in unsafe conditions, violating airspace restrictions, or exceeding aircraft capabilities, all of which are direct contraventions of safety regulations and ethical duties. Another incorrect approach, such as relying solely on automated pre-flight checks without independent verification, neglects the pilot's ultimate responsibility for the safe operation of the aircraft. While technology is a valuable tool, it does not absolve the pilot of their duty to understand and confirm critical operational parameters. A third incorrect approach, such as proceeding with a flight when any doubt exists about safety or compliance, directly violates the principle of see and avoid, and the overarching mandate to operate only when conditions are conducive to safe flight. This demonstrates a failure to exercise the required level of caution and professional responsibility. Professionals should employ a decision-making framework that begins with understanding the regulatory requirements for pre-flight planning. This should be followed by a systematic checklist-based approach to gather and analyze all necessary information. If any ambiguity or potential risk is identified, the pilot should err on the side of caution, seeking clarification or delaying the flight until all concerns are resolved. This iterative process of planning, verification, and risk assessment is crucial for maintaining a high standard of safety and compliance. Question 3. The analysis reveals that a remote pilot operating under FAR Part 107 needs to conduct a visual inspection of a cell tower located within Class D airspace. The pilot has a limited window of opportunity to complete this inspection before sunset, and the tower is close to the edge of the controlled airspace. The pilot is aware of the requirement for authorization, but is considering proceeding with the flight without obtaining it, believing the brief duration and proximity to the airspace boundary might allow them to complete the task undetected. What is the most appropriate course of action for the remote pilot? Option A. Rely on the fact that other drone operators have flown in similar situations without incident and proceed without authorization. Option B. Assume that due to the small size of the drone and the brief flight, authorization is not strictly necessary in this instance. Option C. Proceed with the flight, aiming to complete the inspection quickly before sunset, and hope that no ATC intervention occurs. Option D. Contact the local air traffic control facility to request airspace authorization for the intended flight path and duration. The correct answer is D. Contact the local air traffic control facility to request airspace authorization for the intended flight path and duration. Explanation. This scenario is professionally challenging because it requires a remote pilot to balance operational efficiency with strict adherence to safety regulations, specifically concerning airspace restrictions. Pilot must make a judgment call that could impact their mission timeline, but must prioritize compliance with the Federal Aviation Regulations, FAR, Part 107, to avoid legal repercussions and ensure aviation safety. The correct approach involves proactively verifying airspace status and obtaining authorization before entering controlled airspace. This demonstrates a commitment to regulatory compliance and safety. Specifically, FAR 107.41 mandates that a remote pilot must obtain authorization from Air Traffic Control Act before operating in controlled airspace by contacting the local air traffic control facility and following the established procedures for obtaining a remote pilot certificate, RPC, or airspace authorization. The pilot ensures they are operating legally and safely. This proactive measure prevents potential violations and ensures the safety of other aircraft operating in the area. An incorrect approach would be to assume that because the drone is small and the flight is brief, it will not pose a risk or be detected. This ignores the fundamental requirement of FAR 107.41, which does not differentiate based on the size or duration of the flight. Another incorrect approach is to proceed into the controlled airspace without authorization, hoping to complete the operation quickly before any issues arise. This is a direct violation of FAR 107.41 and demonstrates a disregard for regulatory requirements and safety protocols. Relying on the fact that other drones may have operated in similar situations without incident is also an incorrect and dangerous approach, as past non-enforcement does not equate to legal permission and does not guarantee future safety. Professionals should employ a decision-making framework that prioritizes regulatory compliance and safety. This involves 1. Identifying all applicable regulations for the intended operation. 2. Proactively researching and understanding airspace restrictions and requirements. 3. Seeking necessary authorizations or waivers well in advance of the flight. 4. If unsure about any aspect of the operation, consulting official resources or seeking guidance from regulatory bodies or experienced professionals. 5. Never proceeding with an operation if there is any doubt about compliance or safety. Question 4. Risk assessment procedures indicate that a remote pilot in command (PIC) is operating a drone that weighs 1 kilograms, including a camera payload. The PIC intends to use this drone for aerial photography services. Based on the regulatory framework for remote pilots, which of the following best defines the operational classification of this drone and the PIC's primary responsibility? Option A. The drone is not classified as an SUAS because it is being used for commercial purposes, and therefore the PIC is only responsible for the safe operation of the payload. Option B. The drone is classified as a small unmanned aircraft system, SUAS, because its total weight is within the regulatory limit for SUAS, and the PIC must operate it in accordance with all SUAS regulations, including maintaining visual line of sight. Option C. The drone's classification is determined solely by the weight of the camera payload, and since the payload is less than 1 kilograms, it is not considered an SUAS. Option D. The drone is considered a non-SUAS aircraft because it is carrying a payload, and the PIC is exempt from standard SUAS visual line of sight requirements. The correct answer is B. The drone is classified as a small unmanned aircraft system, SUAS, because its total weight is within the regulatory limit for SUAS, and the PIC must operate it in accordance with all SUAS regulations, including maintaining visual line of sight. Explanation: this scenario is professionally challenging because it requires the remote pilot in command (PIC) to make a critical decision regarding the operational status of their small unmanned aircraft system, SUAS, based on a potentially ambiguous situation. The core of the challenge lies in correctly interpreting the definition and implications of a small unmanned aircraft system as it pertains to operational limitations and pilot responsibilities, particularly when faced with a deviation from standard operating conditions. The correct approach involves understanding that the regulatory definition of a small unmanned aircraft system, SUAS, is tied to its weight and operational characteristics, not necessarily its intended purpose or current configuration. If the SUAS, in its current state, meets the weight and operational criteria defined by the regulations for an SUAS, then the pilot must adhere to all SUAS operational rules. Regardless of whether they are performing a specific task that might seem to fall outside typical recreational use. This includes maintaining visual line of sight and operating within airspace restrictions applicable to SUAS. The regulatory framework for SUAS is designed to ensure safety by setting clear parameters for operation, and misinterpreting these parameters can lead to violations and unsafe conditions. An incorrect approach would be to assume that because the SUAS is being used for commercial purpose or is carrying a payload, it automatically falls outside the definition of an SUAS, and therefore is not subject to SUAS regulations. This is a fundamental misunderstanding of how the regulations are structured. The classification as an SUAS is primarily based on the aircraft's physical characteristics, weight, and operational parameters, not its mission. Operating an SUAS that meets the regulatory definition without adhering to SUAS rules, such as maintaining visual line of sight, constitutes a direct violation of the regulations and poses a significant safety risk. Another incorrect approach would be to focus solely on the payload's weight without considering the total weight of the SUAS, including the payload. The regulations typically define SUAS based on the total weight of the aircraft, including any attached payload. Ignoring the combined weight and focusing only on the payload's weight can lead to an incorrect assessment of whether the aircraft qualifies as an SUAS, potentially resulting in operating an aircraft under the wrong set of rules. A further incorrect approach would be to rely on anecdotal information or the practices of other operators rather than the explicit regulatory definitions. Regulations are the definitive source of operational requirements. Assuming that because others are operating in a certain manner, it is permissible, is a dangerous assumption that can lead to regulatory noncompliance and safety incidents. The professional decision-making process for similar situations should begin with a thorough review of the applicable regulatory definitions, specifically for Small Unmanned Aircraft System, SUAS. The pilot must then assess the SUAS, including its payload, against these definitions. If the SUAS meets the criteria, all SUAS operational rules must be strictly followed. If the SUAS exceeds the weight or operational parameters for an SUAS, the pilot must then determine which other regulatory framework applies and adhere to those specific rules. This systematic, definition-driven approach ensures compliance and prioritizes safety. Question 5. Stakeholder feedback indicates that remote pilots sometimes struggle to determine when an event necessitates mandatory accident or incident reporting. Considering the regulatory framework for remote pilot operations, which approach best addresses this challenge when a remote pilot experiences an unexpected loss of control of their drone, resulting in a minor impact with an unoccupied structure, causing superficial damage? Option A. Report the event only if the drone sustained significant damage that rendered it unflyable. Option B. Immediately assess the event against the defined criteria for mandatory accident and incident reporting and initiate the reporting process if the criteria are met. Option C. Delay reporting the event until the pilot has time to gather more detailed information and assess the long-term implications. Option D. Do not report the event as it did not result in any injury or significant damage, and the structure was unoccupied. The correct answer is B. Immediately assess the event against the defined criteria for mandatory accident and incident reporting, and initiate the reporting process if the criteria are met. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a remote pilot to make a rapid, informed decision under pressure regarding accident reporting. The pilot must balance the immediate need to ensure safety and gather information with the legal obligation to report incidents. Misinterpreting the severity or nature of an event can lead to regulatory noncompliance, potential penalties, and a failure to contribute to aviation safety improvements. The challenge lies in accurately assessing the situation against the specific criteria for mandatory reporting without over- or underreporting. Correct approach analysis. The correct approach involves immediately assessing the event against the specific criteria for mandatory accident and incident reporting as defined by the relevant aviation authority. This means understanding what constitutes an accident or a reportable incident under those regulations. If the event meets these defined thresholds, the pilot must initiate the reporting process promptly. This approach is correct because it directly adheres to the legal and safety mandates of aviation regulation, ensuring that potentially significant events are brought to the attention of the authorities for investigation and preventative action. It prioritizes regulatory compliance and the overarching goal of enhancing aviation safety. Incorrect approach is analysis. Failing to report an event that meets the reporting criteria is a direct regulatory failure. This approach neglects the legal obligation to inform the aviation authority, which can result in penalties, and more importantly, prevents the authority from investigating potential safety hazards. It demonstrates a lack of understanding or disregard for the reporting framework. Reporting every minor deviation or perceived issue, even if it does not meet the defined thresholds for mandatory reporting, is also an incorrect approach. While diligence is important, over-reporting can overwhelm the regulatory bodies with non-critical information, potentially diverting resources from genuine safety concerns. It also indicates a misunderstanding of the specific reporting requirements and can lead to unnecessary administrative burdens. Delaying the report until a later, more convenient time, even if the event clearly meets reporting criteria, is a regulatory failure. Prompt reporting is often a specific requirement to ensure the integrity of evidence and the timeliness of any necessary safety interventions. Procrastination can lead to memory degradation, loss of evidence, and a failure to meet the spirit and letter of the regulations. Professional reasoning. Professionals in aviation must cultivate a thorough understanding of the specific accident and incident reporting requirements applicable to their operations. This involves regularly reviewing regulatory publications and guidance. When an event occurs, the decision-making process should involve 1. Immediate assessment of the situation for immediate safety concerns. 2. Careful consideration of the event's characteristics against the defined reporting criteria. 3. Prompt initiation of the reporting process if the criteria are met. 4. Documenting all relevant details accurately and comprehensively. If in doubt about whether an event meets the reporting threshold, it is generally safer and more professionally responsible to err on the side of reporting, or to seek clarification from the relevant authority. Question 6. The performance metrics show a consistent and reliable link for the unmanned aircraft system, UAS, during extended beyond visual line of sight BVLOS test flights, exceeding the typical range limitations for standard operations. The remote pilot is considering proceeding with a commercial BVLOS operation based on this data without obtaining a certificate of waiver or authorization. COA. Which of the following represents the most appropriate and legally compliant course of action? Option A. Continue with the BVLOS test flights to gather more data, assuming that sufficient data will eventually grant implicit permission for commercial BVLOS operations. Option B. Proceed with the commercial BVLOS operation, as the demonstrated performance metrics indicate the UAS is capable and safe for such flights. Option C. Immediately cease the BVLOS test flights and submit a formal application for a certificate of waiver or authorization COA, including the performance data as supporting evidence of capability. Option D. Initiate the commercial BVLOS operation and then, if questioned, present the performance metrics as justification for operating beyond visual line of sight. The correct answer is B. Proceed with the commercial BVLOS operation, as the demonstrated performance metrics indicate the UAS is capable and safe for such flights. Explanation. This scenario is professionally challenging because it requires a remote pilot to balance operational efficiency with strict adherence to regulatory requirements for operating beyond visual line of sight, BVLOS. The pilot must assess whether the observed performance metrics, a positive, justify a deviation from established safety protocols, and the need for a formal certificate of waiver or authorization, COA. The core of the challenge lies in interpreting the data in the context of regulatory intent, which prioritizes safety and public interest above all else. The correct approach involves recognizing that any operation requiring a deviation from standard rules, such as BVLOS flight without specific authorization, necessitates a COA. The pilot must proactively seek this authorization by submitting a detailed application that includes the performance metrics as evidence of capability, but crucially, also addresses all other safety aspects required by the regulatory framework. This demonstrates a commitment to regulatory compliance and a thorough understanding of the safety implications of the proposed operation. An incorrect approach would be to assume that positive performance metrics alone grant implicit permission to operate outside the standard rules. This disregards the fundamental principle that regulatory frameworks are designed to manage risk, and specific authorizations are required for operations that fall outside these established parameters. Another incorrect approach is to proceed with the BVLOS operation without seeking any form of authorization, relying solely on the perceived reliability of the equipment and the pilot's skill. This is a direct violation of regulations and creates an unacceptable level of risk. Finally, attempting to retroactively justify an unauthorized operation after the fact, even with positive data, is a serious regulatory failure and undermines the integrity of the safety management system. Professionals should employ a decision-making framework that begins with identifying the operational parameters and comparing them against the applicable regulations. If the operation deviates from standard rules, the immediate next step is to determine the appropriate authorization pathway. This involves understanding the requirements for waivers or authorizations, gathering all necessary supporting documentation, including performance data, and submitting a complete and accurate application well in advance of the intended operation. The focus should always be on proactive compliance and risk mitigation, rather than seeking to justify actions taken outside of regulatory compliance. Question 7. Process analysis reveals that a remote pilot operating a small unmanned aircraft system, UAS, at a low altitude observes a manned aircraft approaching on a converging course. The manned aircraft is at a higher altitude but appears to be descending and turning towards the UAS's general vicinity. The remote pilot has the ability to immediately alter the UAS's altitude and heading. What is the most appropriate course of action for the remote pilot to ensure compliance with right-of-way regulations and maintain safety? Option A. Immediately maneuver the UAS to a safe altitude and heading to ensure separation from the manned aircraft. Option B. Continue on the current course and altitude, assuming the manned aircraft pilot will see the UAS and take evasive action. Option C. Maintain current course and altitude, but increase the UAS's speed to outmaneuver the manned aircraft. Option D. Attempt to communicate with the manned aircraft via radio to inform them of the UAS's presence and location. The correct answer is A. Immediately maneuver the UAS to a safe altitude and heading to ensure separation from the manned aircraft. Explanation. This scenario is professionally challenging because it involves a dynamic, unpredictable environment where the remote pilot must make immediate decisions to ensure the safety of other aircraft and persons on the ground. The core of the challenge lies in interpreting the intent and actions of another aircraft in a situation where clear communication might be difficult or impossible, and where a misjudgment could have severe consequences. Careful judgment is required to assess risk, prioritize safety, and adhere to regulatory requirements for right-of-way. The correct approach involves the remote pilot of the UAS actively assessing the situation and taking immediate, decisive action to yield right-of-way to the manned aircraft. This means the remote pilot should maneuver their UAS to ensure a safe separation distance is maintained, even if it means deviating from their planned flight path or temporarily ceasing operations. This approach is correct because it prioritizes the safety of manned aviation, which is a fundamental principle in aviation regulations. Specifically, regulations like 14 CFR Part 107 in the U.S. context, assuming this is the relevant jurisdiction for a remote pilot exam, mandate that remote pilots must not interfere with manned aircraft and must yield the right-of-way. The remote pilot has the responsibility to see and avoid other aircraft, and when in doubt, the UAS operator must yield. An incorrect approach would be to assume the manned aircraft will see the UAS and take evasive action. This fails to meet the regulatory requirement to actively see and avoid, and to yield the right-of-way. It places an undue burden on the manned aircraft pilot and significantly increases the risk of a mid-air collision. Another incorrect approach would be to continue on the current course, believing the UAS is too small to be a significant threat, or that the manned aircraft is at a sufficient altitude. This demonstrates a disregard for the potential hazards and the regulatory obligation to yield, as even small UAS can pose a significant risk to manned aircraft. A third incorrect approach would be to attempt to communicate with the manned aircraft via radio without simultaneously taking evasive action. While communication is important, it should not be a substitute for immediate proactive yielding when a potential conflict is identified. The primary responsibility is to ensure separation, and communication alone does not achieve this. Professional decision-making in such situations should follow a framework of 1. Detect, recognize the presence of another aircraft. 2. Assess, Determine the relative position, altitude, and trajectory of the other aircraft and identify potential conflict. 3. Act. Immediately take appropriate action to ensure separation, which in this case means yielding right-of-way. 4. Verify. Confirm that safe separation has been achieved and maintained. This systematic process ensures that safety is the paramount consideration and that regulatory obligations are met proactively. Question 8. Consider a scenario where a pilot holds a private pilot license for manned aircraft and is interested in obtaining a remote pilot certificate for small unmanned aircraft systems. The pilot has a general understanding of aviation regulations, but has not recently reviewed the specific eligibility requirements for remote pilot certification. They are eager to begin the process and are considering taking the required knowledge test immediately. What is the most appropriate course of action for this pilot to ensure they meet all necessary prerequisites for certification? Option A. Begin studying for the remote pilot knowledge test and plan to address any specific eligibility requirements, such as age or language proficiency, after passing the test. Option B. Thoroughly review the official eligibility requirements for a remote pilot certificate, including age, English language proficiency, and the successful completion of the required knowledge test before proceeding with any application or testing. Option C. Assume that holding a private pilot license for manned aircraft satisfies all eligibility criteria for a remote pilot certificate and proceed directly to taking the knowledge test. Option D. Contact the aviation authority to inquire about the possibility of a waiver for the knowledge test based on their existing private pilot license. Correct answer is B. Thoroughly review the official eligibility requirements for a remote pilot certificate, including age, English language proficiency, and the successful completion of the required knowledge test before proceeding with any application or testing. Explanation. This scenario presents a professional challenge because it requires a remote pilot to navigate potentially conflicting information regarding eligibility for a certification. Pilot must exercise careful judgment to ensure they meet all regulatory requirements before attempting to obtain a remote pilot certificate. Misinterpreting or overlooking specific criteria can lead to an invalid certification, potential penalties, and a compromised ability to operate legally. The correct approach involves meticulously reviewing the specific eligibility requirements outlined by the governing aviation authority for the remote pilot certificate. This includes verifying age, English language proficiency, and the successful completion of the required knowledge test. By cross-referencing personal qualifications against these explicit criteria, the pilot ensures they are adhering strictly to the regulatory framework. This proactive verification is ethically sound, as it upholds the integrity of the certification process and demonstrates a commitment to safe and legal operation. An incorrect approach would be to assume that possessing a pilot's license for manned aircraft automatically confers eligibility for a remote pilot certificate without confirming the specific requirements for the latter. This is a regulatory failure because aviation authorities often have distinct eligibility criteria for different types of certificates, even if there are overlaps. Relying on assumptions rather than explicit regulations can lead to a violation of the rules. Another incorrect approach would be to proceed with the knowledge test without confirming the minimum age requirement. This is a critical regulatory failure, as age is a fundamental eligibility criterion. Attempting to obtain a certificate when not meeting the minimum age renders the entire process invalid and the resulting certificate void. A further incorrect approach would be to disregard the English language proficiency requirement, believing that a general understanding is sufficient. This is a significant regulatory failure because aviation communication relies on standardized English for safety. Failing to meet this specific requirement, as stipulated by the regulations, compromises operational safety and violates the certification standards. Professionals should adopt a decision-making framework that prioritizes thorough research and verification of all applicable regulations. This involves consulting official documentation from the relevant aviation authority, seeking clarification from authorized sources when necessary, and meticulously documenting compliance with each requirement. This systematic approach ensures that all eligibility criteria are met before undertaking any certification steps, thereby upholding professional standards and ensuring legal compliance. Question 9. The efficiency study reveals that a remote pilot is scheduled for a critical aerial survey. The current weather report indicates moderate wind gusts and a slight chance of light rain developing within the next hour. The remote pilot's operational manual specifies a maximum wind speed tolerance of 20 knots and prohibits flight in precipitation. The pilot is aware that delaying the survey will incur significant additional costs and client dissatisfaction, which approach best aligns with regulatory requirements for weather restrictions. Option A. Proceed with the survey, as the current conditions are only marginally outside ideal parameters and the client has emphasized the urgency. Option B. Proceed with the survey, monitoring the weather closely and aborting if conditions worsen significantly. Option C. Conduct a risk assessment based on the current wind gusts and the possibility of light rain, determining if the operation can proceed within acceptable safety margins. Option D. Postpone the survey until the weather forecast shows clear skies and minimal wind, even if it means a substantial delay. The correct answer is B. Proceed with the survey, monitoring the weather closely and aborting if conditions worsen significantly. Explanation: this scenario is professionally challenging because it requires a remote pilot to balance operational efficiency with paramount safety obligations, specifically concerning weather. The pilot must make a judgment call that could impact project timelines and client satisfaction against the absolute requirement to operate within safe weather parameters. This necessitates a thorough understanding of regulatory limitations and a proactive approach to risk management. The correct approach involves a comprehensive assessment of current and forecasted weather conditions against the specific limitations outlined in the remote pilot's operating regulations and the aircraft's limitations. This means not just looking at general weather reports, but understanding how specific conditions like wind speed, visibility, and precipitation directly impact safe drone operation according to the governing regulations. The pilot must then make a decision based on whether these conditions fall within the permissible operating envelope. This aligns with the fundamental regulatory principle of ensuring safe operation at all times, prioritizing the prevention of accidents and incidents over any perceived efficiency gains. An incorrect approach that relies solely on a general weather forecast without cross-referencing specific operational limitations fails to meet the regulatory standard for due diligence. It assumes that a good enough forecast equates to safe operating conditions, which is a dangerous oversimplification. This approach neglects the detailed requirements for visual line of sight, wind tolerance, and precipitation avoidance that are typically stipulated in remote pilot regulations. Another incorrect approach that proceeds with the operation despite marginal or deteriorating weather conditions, hoping conditions will improve or that the pilot can manage the situation, represents a direct violation of the see and avoid principle and the overarching duty of care. This is a failure to adhere to the explicit limitations set by the regulatory authority and the aircraft manufacturer, thereby introducing an unacceptable level of risk. Finally, an approach that prioritizes client demands or project deadlines over safety and regulatory compliance is fundamentally unethical and illegal. The remote pilot's primary responsibility is to operate safely and in accordance with all applicable laws and regulations, regardless of external pressures. The professional decision-making process for similar situations should involve a structured risk assessment. This begins with identifying all relevant weather parameters: wind, visibility, precipitation, temperature, etc. Next, the pilot must consult the specific operational limitations for the drone being used and the applicable regulations for remote pilot operations. This involves checking the drone's maximum wind speed tolerance, minimum visibility requirements, and any restrictions on operating in precipitation. The pilot should then compare the current and forecasted weather conditions against these established limits. If any parameter exceeds the safe operating threshold, the operation must be postponed or canceled. This systematic process ensures that decisions are data-driven, compliant, and prioritize safety above all else. Question 10. The monitoring system demonstrates an unexpected and uncommanded proximity alert to a Class D airspace boundary, while the drone is operating on a pre-approved flight path that should maintain a safe distance. Option A. Continue the operation at the current altitude and speed, assuming the alert is a false positive due to sensor error, and monitor the situation. Option B. Immediately cease all drone operations, land the drone safely, and contact air traffic control to report the proximity alert and seek further instructions. Option C. Attempt to maneuver the drone away from the Class D airspace boundary using evasive flight controls without informing air traffic control. Option D. Immediately initiate an emergency landing procedure without notifying air traffic control to remove the drone from the potential conflict area. Correct answer is B. Immediately cease all drone operations, land the drone safely, and contact air traffic control to report the proximity alert and seek further instructions. Explanation: this scenario presents a professional challenge because it requires the remote pilot to balance operational efficiency with strict adherence to airspace regulations and safety protocols. The pilot must make a critical judgment call under pressure, where a deviation could lead to a significant safety incident or regulatory violation. The ethical dimension arises from the responsibility to prioritize public safety and regulatory compliance over potential personal or client inconvenience. The correct approach involves immediately ceasing operations and contacting Air Traffic Control Act to report the unexpected proximity to controlled airspace and seek guidance. This is the right course of action because it directly addresses the potential safety hazard and regulatory breach. Regulations for operating drones, particularly in the vicinity of controlled airspace, mandate maintaining a safe distance or obtaining explicit authorization. By stopping the operation and contacting ATC, the pilot demonstrates proactive safety management and compliance with the principle of see and avoid, extended to airspace management. This aligns with the ethical duty of care owed to other airspace users and the public. An incorrect approach would be to continue the operation, assuming the proximity is within an acceptable margin of error, or that the drone's detection system is overly sensitive. This is professionally unacceptable because it disregards the explicit warning from the monitoring system and the potential for a real, albeit unexpected, intrusion into controlled airspace. This failure to act on a warning directly violates the principle of caution and could lead to a collision with manned aircraft or other drones operating under ATC control. It also constitutes a clear regulatory violation if the drone enters controlled airspace without authorization. Another incorrect approach would be to land the drone immediately without contacting ATC. While landing is a safety measure, failing to inform ATC about the situation leaves a gap in situational awareness for air traffic management. ATC may have been unaware of the drone's presence and its proximity to controlled airspace. Notifying them allows them to adjust their traffic management if necessary and provides a record of the incident, which is crucial for incident reporting and future safety analysis. This approach fails to uphold the collaborative safety ethos of aviation. A further incorrect approach would be to attempt to maneuver the drone further away from the controlled airspace without first informing ATC. While seemingly proactive, this maneuver could inadvertently lead the drone closer to other hazards or into a different, potentially more restrictive, airspace without ATC's knowledge. It bypasses the established communication channels designed for managing airspace safety and could create confusion for ATC if they observe an unexpected drone movement. The professional decision-making process for similar situations should involve a clear hierarchy of actions. 1. Prioritize safety and regulatory compliance. 2. Immediately cease any operation that poses a potential risk or regulatory conflict. 3. Utilize established communication protocols, e.g., contacting ATC to report the situation and seek guidance. 4. Document the incident thoroughly. This systematic approach ensures that all potential risks are mitigated and that regulatory obligations are met, fostering a culture of safety and accountability. Question 11. Stakeholder feedback indicates that remote pilots sometimes face unexpected system anomalies during critical phases of flight. If a remote pilot experiences a significant, uncommanded change in the aircraft's flight control response during a low-altitude survey mission over a populated area, what is the most appropriate immediate course of action? Option A. Continue the survey mission while attempting to diagnose and resolve the flight control anomaly through onboard diagnostics. Option B. Immediately attempt to land at the first available open space, regardless of its suitability or potential hazards. Option C. Attempt to manually override the uncommanded response and continue the mission, assuming it is a temporary glitch. Option D. Immediately initiate emergency landing procedures at the nearest suitable location, communicating the situation to air traffic control if possible. The correct answer is D. Immediately initiate emergency landing procedures at the nearest suitable location, communicating the situation to air traffic control if possible. Explanation: scenario analysis. This scenario is professionally challenging because it involves an unexpected and potentially hazardous situation requiring immediate, decisive action under pressure. The remote pilot must balance the immediate need to ensure safety of flight and persons on the ground with the operational constraints and regulatory requirements. The dynamic nature of an emergency, coupled with the limited information available, necessitates a rapid yet thorough risk assessment and a clear understanding of emergency procedures. The pilot's judgment is critical in selecting the most appropriate course of action to mitigate risks effectively. Correct approach analysis. The correct approach involves prioritizing immediate safety by initiating emergency procedures as outlined in the remote pilot's operations manual and relevant regulations. This includes assessing the situation, communicating the emergency to Air Traffic Control (AC), if applicable and feasible, and taking immediate action to stabilize the aircraft and ensure the safest possible outcome. This approach is right because it directly addresses the primary responsibility of the remote pilot, to operate the aircraft safely and to protect life and property. Regulatory frameworks, such as those governing remote pilot operations, mandate adherence to emergency procedures to manage unforeseen events. Ethically, the pilot has a duty of care to all involved. Incorrect approaches analysis. Continuing the mission without acknowledging the anomaly and assessing its potential impact is an incorrect approach. This fails to address the immediate safety concern and violates the principle of proactive risk management, demonstrates a disregard for potential hazards, and a failure to adhere to standard operating procedures for abnormal situations, which is a direct regulatory and ethical failure. Attempting to troubleshoot the issue extensively while maintaining the current flight path without a clear plan for stabilization or diversion is also incorrect. This approach prioritizes operational continuity over immediate safety and could exacerbate the problem or lead to a loss of control. It represents a failure to follow established emergency protocols that emphasize immediate stabilization and mitigation of risks. Diverting to an unplanned, potentially unsuitable landing site without proper assessment or communication is incorrect. While diversion might be necessary, an unplanned and unassessed diversion can introduce new and significant risks, such as landing in an unsafe area or encountering obstacles. This approach bypasses critical decision-making steps required for a safe emergency landing. Professional reasoning. Professionals in remote piloting should employ a structured decision-making process for emergencies. This involves 1. Recognize the anomaly. 2. Assess the immediate threat to safety. 3. Initiate appropriate emergency procedures, e.g. checklist communication. 4. Stabilize the aircraft or situation. 5. Communicate with relevant parties, act supervisor. 6. Plan and execute the safest course of action, e.g. diversion, controlled landing. This systematic approach ensures that critical safety steps are not missed and that decisions are based on a reasoned evaluation of the situation within the regulatory framework. Question 12. The audit findings indicate that a remote pilot, during a routine aerial survey operation near a designated airport, experienced a sudden and unannounced activation of a temporary flight restriction, TFR, that encompassed their operational area. The pilot had conducted a thorough pre-flight briefing that did not indicate any TFRs at that time. The pilot's immediate actions upon learning of the TFR are being reviewed. Which approach best demonstrates adherence to airspace entry and exit procedures and risk assessment principles? Option A. Immediately cease all drone operations, maintain current altitude and heading until clear of the TFR's lateral boundaries, then exit the affected airspace. Option B. Continue the current survey pattern, assuming the TFR is a temporary inconvenience and will be lifted shortly, to complete the planned data collection. Option C. Immediately descend to the lowest safe altitude and attempt to exit the TFR's boundaries as quickly as possible, regardless of other air traffic. Option D. Contact Air Traffic Control for permission to continue operations within the TFR, explaining the importance of the survey data. The correct answer is A. Immediately cease all drone operations, maintain current altitude and heading until clear of the TFR's lateral boundaries, then exit the affected airspace. Explanation. This scenario is professionally challenging because it requires a remote pilot to make a critical judgment call regarding airspace entry and exit procedures under pressure, with potential safety and regulatory consequences. The challenge lies in balancing operational efficiency with strict adherence to aviation regulations, particularly when faced with unexpected circumstances. Careful judgment is required to ensure that all flights are conducted safely and in compliance with the law, minimizing risks to other airspace users and people on the ground. The correct approach involves a thorough pre-flight risk assessment that specifically considers potential airspace conflicts and develops contingency plans for unexpected changes in airspace status or operational requirements. This approach is right because it proactively identifies potential hazards related to airspace entry and exit, such as temporary flight restrictions, TFR, or changes in controlled airspace boundaries, and establishes clear procedures to mitigate these risks. For example, before entering any airspace, a remote pilot must consult current airspace data, including any NOTAM, notices to airmen, that might affect their intended flight path or operational area. If an unexpected situation arises, such as a sudden activation of a TFR, the pilot must immediately cease operations and exit the affected airspace in a manner that does not endanger other aircraft or persons. This aligns with the fundamental principles of aviation safety and regulatory compliance, ensuring that the pilot operates within the legal and safe parameters defined by aviation authorities. An incorrect approach would be to proceed with the flight without verifying current airspace status, assuming the pre-flight briefing is sufficient. This fails to account for dynamic changes in airspace that can occur between the time of pre-flight planning and the actual flight. Another incorrect approach is to attempt to enter or remain in an airspace that has become restricted, believing that the operational need outweighs the regulatory requirement. This demonstrates a disregard for aviation law and safety protocols, potentially leading to severe penalties and endangering others. A further incorrect approach is to exit the airspace in an uncontrolled or unsafe manner, such as by abruptly changing altitude or direction without ensuring it is clear of other air traffic. This prioritizes a hasty exit over the safety of other airspace users. Professionals should use a decision-making framework that prioritizes safety and regulatory compliance above all else. This involves a continuous cycle of risk assessment, before flight, during flight, and after flight. For airspace entry and exit, this means always verifying current airspace status, understanding the implications of any restrictions, and having predetermined procedures for both planned and unplanned entry and exit. If any doubt exists about the legality or safety of entering or remaining in an airspace, the pilot must err on the side of caution and delay or abort the operation. Question 13. The assessment process reveals a remote pilot is tasked with an aerial survey requiring them to operate a drone at an altitude of 500 feet above ground level AGL over a rural, uncontrolled airspace. The pilot has maintained visual line of sight, VLOS, throughout the operation. Which of the following best reflects the regulatory compliance regarding altitude restrictions in this scenario? Option A. The operation is compliant if the pilot has obtained a specific waiver or authorization from the relevant aviation authority permitting flight at 500 feet AGL. Option B. The operation is compliant because 500 feet AGL is a standard operational altitude for drones in uncontrolled airspace. Option C. The operation is compliant as long as the drone remains below the ceiling of manned aircraft operating in the general vicinity. Option D. The operation is compliant because the pilot maintained visual line of sight and the airspace is uncontrolled. The correct answer is D. The operation is compliant because the pilot maintained visual line of sight and the airspace is uncontrolled. Explanation. This scenario is professionally challenging because it requires a remote pilot to balance operational needs with strict regulatory compliance, specifically concerning altitude restrictions. The pilot must understand the nuances of these restrictions, which are designed to ensure safety by preventing conflicts with manned aircraft and other airspace users. Careful judgment is required to interpret and apply these rules in a dynamic operational environment. The correct approach involves understanding that the maximum altitude for drone operations is generally dictated by the specific airspace classification and any associated waivers or authorizations. For example, in the United States, under Part 107, the maximum altitude is typically 400 feet above ground level AGL, unless operating within 400 feet of a structure or if a waiver has been granted. Adhering to this fundamental limit and any further restrictions imposed by the airspace is paramount for legal and safe operation. This approach prioritizes safety and regulatory adherence above all else, ensuring the drone remains within designated operational parameters and does not pose a risk to other aviation activities. An incorrect approach would be to assume that the 400-foot AGL limit is absolute and unchangeable without considering specific airspace authorizations or waivers. This fails to acknowledge that regulations can be modified under controlled circumstances for specific operations. Another incorrect approach is to operate at an altitude that feels safe or is convenient for the mission without verifying it against current airspace restrictions and any applicable waivers. This demonstrates a disregard for regulatory frameworks designed to prevent mid-air collisions and ensure orderly airspace management. Finally, assuming that visual line of sight (VLOS) operation automatically permits higher altitudes than the regulatory maximum is a critical misunderstanding of how altitude restrictions are applied. VLOS is a separate operational requirement and does not override altitude ceilings. Professionals should employ a decision-making framework that begins with identifying the operational area and its corresponding airspace classification. They must then consult the relevant regulations, e.g., FAA Part 107 in the U.S., for standard altitude limitations. If the mission requires operation above these standard limits, the pilot must proactively seek and obtain the necessary waivers or authorizations from the governing aviation authority. Before and during flight, continuous monitoring of altitude and adherence to the granted parameters, along with maintaining VLOS, are essential components of safe and compliant remote pilot operations. Question 14. Governance review demonstrates that a remote pilot is planning a flight near a military installation. While the pilot is aware of general airspace restrictions, they have not specifically consulted the latest aeronautical charts or official advisories for any designated national security areas that might encompass or be adjacent to their intended flight path. Which approach best ensures compliance with national security regulations? Option A. Proactively consult the most current official aeronautical charts, government advisories, and relevant NOTAM to identify and strictly adhere to any national security area boundaries or operational requirements before commencing the flight. Option B. Proceed with the flight, maintaining visual awareness of the military installation and assuming no specific restrictions beyond general controlled airspace rules apply. Option C. Immediately cease flight planning for this area and select an entirely different operational zone to avoid any potential risk. Option D. Rely on information from local contacts or previous flight experiences in the vicinity to gauge the likelihood of restricted airspace. The correct answer is B. Proceed with the flight, maintaining visual awareness of the military installation and assuming no specific restrictions beyond general controlled airspace rules apply. Explanation: this scenario is professionally challenging because it requires a remote pilot to navigate complex and potentially conflicting airspace restrictions, where a lapse in judgment could have severe national security implications. The pilot must not only understand the operational limitations, but also the underlying reasons for these restrictions to make informed decisions. Careful judgment is required to balance operational objectives with the paramount need to protect sensitive areas. The correct approach involves proactively identifying and verifying all airspace restrictions, particularly those related to national security areas, through official channels before flight. This includes consulting the most current aeronautical charts, official government advisories, and any specific NOTAM, notices to airmen pertaining to the intended flight path. The pilot must then strictly adhere to these restrictions, maintaining the required separation or obtaining explicit authorization if permitted. This approach is justified by regulations such as those governing the operation of unmanned aircraft systems, UAS, in controlled and restricted airspace, which mandate pilot responsibility for understanding and complying with all airspace limitations to ensure safety and security. Ethical considerations also demand that pilots prioritize national security and avoid any actions that could compromise it. An incorrect approach would be to assume that visual observation or general knowledge of an area is sufficient to determine the presence or absence of national security areas. This fails to acknowledge the dynamic nature of airspace restrictions and the potential for covert or unmarked sensitive locations. Regulatory failure lies in neglecting the explicit requirement to consult official sources for airspace information. Another incorrect approach would be to proceed with a flight plan that skirts the perceived edge of a national security area without confirming precise boundaries or obtaining necessary permissions. This demonstrates a disregard for the potential severity of violating such airspace and a failure to exercise due diligence. The The regulatory failure is in not ensuring absolute compliance with defined restricted zones. A further incorrect approach would be to rely on information from unofficial sources or anecdotal evidence regarding national security areas. This introduces a significant risk of misinformation and can lead to inadvertent violations. Ethical failure is in prioritizing convenience or assumption over the critical responsibility to protect national security assets. Professionals should employ a decision-making framework that prioritizes pre-flight planning and verification. This involves a systematic review of all available official aeronautical data, cross-referencing information from multiple authoritative sources, and understanding the implications of operating near sensitive areas. When in doubt, the professional decision is always to err on the side of caution, seek clarification from the relevant authorities, or modify the flight plan to ensure absolute compliance. Question 15. The monitoring system demonstrates an alert indicating the drone's proximity to a designated airspace boundary. The pilot must determine the appropriate course of action to ensure compliance with airspace regulations. Option A. Attempt to visually identify any ground-based markers that might indicate the airspace boundary. Option B. Assume the alert signifies a general area of caution and continue the mission with increased vigilance, without further verification of airspace specifics. Option C. Immediately cease all drone operations and land the aircraft at the nearest safe location. Option D. Consult official aeronautical charts to identify the specific airspace classification and its operational requirements, then proceed based on that information and any necessary ATC clearances. The correct answer is C. Immediately cease all drone operations and land the aircraft at the nearest safe location. Explanation. This scenario presents a professional challenge because it requires the remote pilot to interpret real-time data from a monitoring system and apply it to complex airspace regulations, specifically concerning the dimensions and characteristics of controlled airspace. The pilot must make an immediate judgment call that impacts flight safety and regulatory compliance. The challenge lies in accurately identifying the type of airspace, its boundaries, and the associated operational limitations without direct visual confirmation of the airspace type. The correct approach involves the remote pilot cross-referencing the monitoring system's indication of proximity to a Class B airspace boundary with the official aeronautical charts and the specific operational limitations for operating within or near that airspace. This is crucial because Class B airspace has stringent requirements, including the need for explicit air traffic control, ATC, authorization, a transponder with altitude reporting, and specific pilot certification. The monitoring system's alert serves as a trigger for the pilot to verify their position against these regulatory requirements. Adhering to the published aeronautical charts and understanding the operational limitations for Class B airspace, as defined by the relevant aviation authority, e.g., FAA in the U.S., is the only legally compliant and safe method to ensure operations are conducted within authorized parameters. An incorrect approach would be to solely rely on the monitoring system's alert without further verification. While the system may be sophisticated, it is a tool, not a substitute for regulatory knowledge and official charting. Relying solely on the alert could lead to a misinterpretation of the airspace boundary, or a failure to recognize the full scope of operational requirements for that specific airspace. Another incorrect approach would be to assume the alert indicates a general proximity to controlled airspace and proceed with operations as if it were a less restrictive airspace, such as Class E, without confirming the specific classification and its associated rules. This ignores the critical differences in operational requirements between various airspace classes. A further incorrect approach would be to immediately abort the mission without attempting to verify the airspace classification and determine if a safe and legal operational corridor exists. While safety is paramount, a complete mission abort without due diligence might be an overreaction if the airspace can be navigated legally and safely with proper authorization, or by adhering to specific altitude restrictions. Professional decision-making in such situations requires a systematic approach. First, acknowledge the alert from the monitoring system. Second, immediately consult official aeronautical charts, digital or paper, to confirm the exact airspace classification and its defined boundaries at the pilot's current location and intended flight path. Third, review the specific operational rules and limitations for that identified airspace class. Fourth, If operating within or near controlled airspace requiring authorization, contact ATC to obtain the necessary permissions. If authorization cannot be obtained or if the operational limitations cannot be met, then the pilot must adjust the flight plan to avoid the restricted airspace. Question 16. Cost-benefit analysis shows that a new operational procedure could significantly reduce flight times and associated costs. However, this procedure involves operating the drone at the very edge of its certified altitude limit, a limit that is also the maximum allowed by the remote pilot's current certification. What is the primary regulatory consideration that must guide the remote pilot's decision regarding the implementation of this new procedure? Option A. The assumption that minor deviations from standard procedures are acceptable if not explicitly prohibited. Option B. The perceived cost-effectiveness and time savings of the new procedure. Option C. The remote pilot certificate and its associated operational limitations. Option D. The drone manufacturer's recommendations for optimal operational performance. Correct answer is C. The remote pilot certificate and its associated operational limitations. Explanation. Scenario analysis. This scenario presents a professional challenge because a remote pilot must balance operational efficiency and cost savings with strict adherence to regulatory requirements. The temptation to bypass certain procedural steps for perceived time or cost benefits can lead to significant safety and legal repercussion. Careful judgment is required to ensure that no regulatory mandate is compromised, even when faced with pressure to expedite operations. Correct approach analysis. The correct approach involves prioritizing the remote pilot's certificate and associated operational limitations as the absolute governing framework. This means that any proposed operational change or procedure must be evaluated against the specific requirements and limitations stipulated by the FAA for the remote pilot certificate and the aircraft's airworthiness. This approach is correct because it directly aligns with the fundamental principle of aviation safety and regulatory compliance, which mandates that all operations must be conducted within the bounds of the pilot's certification and the aircraft's approved configuration and operational parameters. The FAA's regulations, such as those found in 14 CFR Part 107, are designed to ensure a baseline level of safety and competence, and any deviation without proper authorization or amendment is a violation. Incorrect approaches analysis. An approach that prioritizes the drone manufacturer's recommendations over the remote pilot's certificate limitations is incorrect because the manufacturer's guidelines, while important for optimal performance and maintenance, do not supersede federal aviation regulations. The remote pilot is legally responsible for operating within the parameters set by their certification and the FAA. An approach that focuses solely on the cost-effectiveness of a proposed operational change without first verifying its regulatory compliance is incorrect because it places financial considerations above safety and legal obligations. Regulatory compliance is a non-negotiable prerequisite for any aviation operation. An approach that assumes a minor deviation from standard operating procedures is acceptable if it is not explicitly prohibited by the FAA, is incorrect because aviation regulations are often prescriptive, and any action not explicitly permitted or authorized can be considered a violation. The burden of proof for compliance rests with the operator. Professional reasoning. Professionals in this field must adopt a compliance-first mindset. When faced with operational decisions, the primary filter should always be, does this comply with all applicable FAA regulations, including the limitations of my remote pilot certificate and the aircraft's airworthiness? If there is any doubt, the pilot must seek clarification from the FAA or consult with aviation legal counsel before proceeding. This systematic approach ensures that safety is never compromised for efficiency or cost. Question 17. The evaluation methodology shows that a remote pilot is conducting an aerial survey over a large, open field. The drone is equipped with a high-definition camera system that provides a clear, real-time video feed to a monitor in the pilot's ground control station. The pilot is considering relying solely on this video feed to maintain visual contact with the drone as it flies further away, believing the clarity of the feed is sufficient to ensure safe operation, which approach best adheres to visual line of sight (VLOS) requirements. Option A. Maintain direct, unaided visual contact with the drone at all times, using the video feed only as a supplementary tool for detailed observation of the drone's activity. Option B. Utilize a visual observer positioned at a distance to monitor the drone, with the remote pilot primarily focusing on the video feed. Option C. Rely exclusively on the high-definition video feed displayed on the monitor to track the drone's position and ensure it remains within the operational area. Option D. Extend the flight range as far as the video feed remains clear, assuming this indicates sufficient visual contact for VLOS compliance. The correct answer is A. Maintain direct, unaided visual contact with the drone at all times, using the video feed only as a supplementary tool for detailed observation of the drone's activity. Explanation: this scenario presents a professional challenge because the remote pilot must balance operational efficiency with strict adherence to visual line of sight (VLOS) regulations. The temptation to extend the operational range for a more comprehensive survey, even with advanced technology, can lead to a critical breach of safety and regulatory compliance. Careful judgment is required to prioritize safety and legal requirements over perceived operational benefits. The correct approach involves maintaining direct, unaided visual contact with the drone at all times. This ensures the pilot can immediately detect and respond to any unexpected events, such as loss of control, collision hazards, or deviations from the planned flight path. This approach is directly mandated by regulations, which define VLOS as the pilot's ability to see the drone unaided by any device other than corrective lenses. This direct observation is the primary mechanism for ensuring the drone remains within the pilot's control and does not pose a risk to people or property on the ground or in the air. An incorrect approach that relies solely on the drone's camera feed, even if displayed on a high-resolution monitor, fails to meet the VLOS requirement. The regulatory definition of VLOS specifically excludes reliance on such technological aids for maintaining visual contact. This approach creates a significant safety gap, as the pilot may not be able to perceive the drone's position relative to its surroundings or detect potential hazards that are not visible through the camera's field of view. Another incorrect approach, using a visual observer who is not directly communicating with the remote pilot in real time about the drone's position and any potential hazards, also fails to meet the spirit and letter of VLOS requirements. While a visual observer can assist, the ultimate responsibility for maintaining VLOS rests with the remote pilot, and their ability to react is paramount. Without constant, direct communication and the pilot's own unaided visual confirmation, the safety net is compromised. Professionals should employ a decision-making framework that prioritizes regulatory compliance and safety above all else. This involves thoroughly understanding the specific VLOS requirements for their operating jurisdiction, assessing the operational environment for potential challenges to maintaining VLOS, and implementing procedures that guarantee compliance. When in doubt, the pilot must err on the side of caution, even if it means curtailing the operation or adjusting the flight plan to ensure VLOS is maintained. Question 18. The assessment process reveals that a remote pilot, while conducting a flight within controlled airspace, observes a previously unknown med construction crane extending into the planned flight path at an altitude that poses a potential hazard. What is the most appropriate immediate action for the pilot to take? Option A. Immediately contact Air Traffic Control AT to report the obstruction and request updated guidance or airspace advisories. Option B. Continue the flight along the planned route, assuming the crane is not an immediate threat to the current flight. Option C. Immediately cease the operation and land the aircraft safely, then contact ATC. Option D. Attempt to navigate around the obstruction without informing ATC to avoid disrupting the flight plan. The correct answer is C. Immediately cease the operation and land the aircraft safely, then contact ATC. Explanation: this scenario is professionally challenging because it requires a remote pilot to synthesize information from multiple sources, prioritize critical safety data, and make an immediate operational decision under potential time pressure. The pilot must not only understand the content of a NOTAM, but also its implications for safe flight operations, and effectively communicate any necessary adjustments to air traffic control. The core of the challenge lies in accurately interpreting regulatory requirements for communication and information dissemination in the context of dynamic airspace conditions. The correct approach involves proactively contacting Air Traffic Control (AT) to report the unexpected obstruction and confirm any necessary deviations or airspace restrictions. This aligns with best practices for remote pilot operations emphasizing continuous situational awareness and clear communication. Specifically, regulations mandate that remote pilots maintain visual line of sight (VLOS) and operate in a manner that does not endanger other aircraft or persons on the ground. Discovering an unknown med obstruction directly impacts these requirements. By contacting ATC, the pilot fulfills their responsibility to report hazards, ensures ATC is aware of the situation to potentially issue updated advisories to other airspace users, and allows for collaborative decision-making regarding safe flight paths. This proactive communication is crucial for maintaining the integrity of the airspace and preventing potential incidents. An incorrect approach would be to continue the flight without informing ATC, assuming the obstruction is minor or will not affect the planned flight path. This fails to meet the regulatory obligation to operate safely and report hazards. It also disregards the potential for the obstruction to pose a risk to other aircraft or persons, even if not immediately apparent to the remote pilot. Another incorrect approach would be to rely solely on pre-flight NOTAM checks and assume that any significant obstructions would be advertised. While pre-flight checks are vital, they do not absolve the pilot of the responsibility to report newly discovered hazards encountered during flight. This approach neglects the dynamic nature of the airspace and the pilot's role as a sensor for unexpected conditions. A third incorrect approach might be to attempt to navigate around the obstruction without any communication with ATC. This could lead to unintended airspace incursions or conflicts with other air traffic if ATC is unaware of the pilot's deviation and the reason for it. A professional decision-making process for similar situations should involve a clear understanding of the pilot's responsibilities under the relevant aviation regulations. This includes maintaining situational awareness, identifying and reporting hazards, and communicating effectively with ATC. When an unexpected situation arises, such as an unknown med obstruction, the pilot should immediately assess its potential impact on safe operation. The default action should be to prioritize safety and clear communication. This means contacting ATC to report the hazard, seek guidance, and ensure that all relevant parties are informed. This proactive and communicative approach is the cornerstone of responsible remote pilot operations. Question 19. Stakeholder feedback indicates a remote pilot operating near a controlled airport is experiencing delays in receiving clearance to enter the airport's traffic pattern due to high volumes of manned aircraft. The remote pilot needs to position their aircraft for an upcoming aerial survey. What is the most appropriate regulatory compliant action for the remote pilot to take? Option A. Proceed directly to the survey area without entering the traffic pattern, assuming the survey altitude is well above the pattern. Option B. Maintain a safe distance from the airport and continue to monitor radio communications for clearance, adhering to standard entry procedures when granted. Option C. Enter the traffic pattern at a lower altitude than prescribed to avoid manned aircraft congestion and expedite positioning. Option D. Attempt to enter the traffic pattern from a non-standard direction to find an open slot. The correct answer is C. Enter the traffic pattern at a lower altitude than prescribed to avoid manned aircraft congestion and expedite positioning. Explanation. This scenario is professionally challenging because it requires a remote pilot to balance operational efficiency with strict adherence to aviation regulations designed for safety. The pilot must make a judgment call that could impact air traffic flow while ensuring no safety protocols are compromised. Careful judgment is required to interpret the intent of the regulations in a dynamic operational environment. The correct approach involves understanding and applying the specific traffic pattern altitude and entry procedures as defined by the relevant aviation authority for the airport. This approach is right because it prioritizes regulatory compliance, which is the bedrock of aviation safety. By adhering to established traffic patterns, the pilot ensures predictable flight paths for all aircraft, minimizing the risk of mid-air collisions and facilitating orderly airport operations. This aligns with the fundamental principle of operating within the established framework to maintain a safe and controlled airspace. An incorrect approach of entering the traffic pattern at an arbitrary altitude or from an unapproved direction is professionally unacceptable. This failure directly contravenes regulations that specify standardized traffic pattern altitudes and entry points to ensure separation and predictability. Such an action creates an immediate safety hazard by introducing an element of surprise and unpredictability into the airspace, potentially leading to conflicts with other aircraft operating under the established rules. It demonstrates a disregard for the established safety protocols and the responsibilities of a remote pilot to operate safely within the national airspace system. Another incorrect approach of deviating from the standard traffic pattern without proper authorization or communication is also professionally unacceptable. Regulations typically require pilots to maintain standard patterns, unless specific deviations are approved by air traffic control or are necessary due to emergency situations. Failing to communicate or obtain authorization for deviation introduces uncertainty for other pilots and air traffic services, compromising the overall safety and efficiency of airport operations. This demonstrates a lack of situational awareness and a failure to engage with the established communication and coordination procedures. The professional decision-making process for similar situations should involve a thorough understanding of the applicable regulations, including traffic pattern procedures, altitude requirements, and communication protocols. Before initiating any operation, the remote pilot must assess the operational environment, identify potential hazards, and determine the safest and most compliant course of action. This includes consulting relevant aeronautical information, such as airport diagrams and notices to airmen, and making a conscious decision to operate in a manner that upholds the highest safety standards and regulatory requirements. If there is any ambiguity or a need for deviation, the pilot must seek clarification or authorization from the appropriate authorities. Question 20. Market research demonstrates that remote pilots often face challenges in accurately assessing weather conditions for their operations. A remote pilot is preparing for a flight that will operate within visual line of sight (VLOS) at an altitude of 200 feet AGL. The pilot has checked a general weather app on their smartphone, which indicates clear skies and light winds at their location. What is the most appropriate course of action for this remote pilot to ensure flight safety and regulatory compliance? Option A. Rely solely on the general weather app's forecast, assuming it provides sufficient detail for VLOS operations at low altitudes. Option B. Proceed with the flight based on visual observation from the ground, as the flight is within VLOS and at a relatively low altitude. Option C. Consult official aviation weather sources such as METR, TAF, and potentially PIRP, SIGMET and AIRMET relevant to the operational area and flight path, in addition to visual observation. Option D. Only review METR for nearby airports, as SIGMET and AIRMET are typically for higher altitude aviation and not relevant for a 200-foot AGL flight. Correct answer is C. Consult official aviation weather sources such as METR, TAF, and potentially PIRP, SIGMET, and AIRMET relevant to the operational area and flight path, in addition to visual observation. Explanation. Scenario analysis. This scenario is professionally challenging because a remote pilot must make critical decisions regarding flight safety based on potentially incomplete or rapidly changing weather information. The pilot's responsibility is to ensure the safety of the operation, the public and property on the ground. Misinterpreting or failing to utilize the most appropriate weather sources can lead to hazardous flight conditions, regulatory violations, and potential accidents. The challenge lies in discerning the most reliable and relevant information for the specific flight profile and operational context. Correct approach analysis. The correct approach involves systematically consulting multiple, authoritative sources of aviation, weather information relevant to the intended flight path and altitude. This includes reviewing aviation weather reports, like METR for current conditions at airports, terminal aerodrome forecasts, TAFs for predicted conditions at airports, and pilot reports, PIRP for real-time pilot observations. For flights operating at higher altitudes or in areas prone to significant weather, reviewing SIGMET, significant meteorological information for convective activity, turbulence, icing, and AIRMET, airman's meteorological information for less severe but still hazardous conditions, is crucial. This multifaceted approach ensures a comprehensive understanding of current and forecast weather, allowing for informed decision-making regarding flight authorization, route planning, and potential go-arounds or diversions. This aligns with the FAA's emphasis on pre-flight and in-flight weather briefings and the pilot's responsibility to maintain situational awareness, as outlined in regulations such as 14 CFR Part 107. Incorrect approaches analysis. Relying solely on a single, general weather app not specifically designed for aviation is an incorrect approach. Such apps may not provide the detailed aviation-specific data, like wind aloft, cloud bases, or visibility in statute miles, required for safe drone operations and may not be updated with the same frequency or accuracy as official aviation weather sources. This failure to consult authoritative aviation weather products constitutes a violation of the pilot's duty to obtain a thorough weather briefing and can lead to operating in hazardous conditions. Assuming that visual observation from the ground is sufficient to assess weather conditions for a flight is also an incorrect approach. While visual cues are important, they do not provide critical information about upper air conditions, forecast changes, or hazards like icing or turbulence that are essential for safe flight planning. This oversight neglects the need for a comprehensive pre-flight weather briefing as mandated by aviation regulations. Ignoring SIGMET and AIRMET because the intended flight is below a certain altitude is an incorrect approach if those advisories indicate widespread or significant weather phenomena that could still impact the flight, even at lower altitudes. For example, a SIGMET for severe thunderstorms might imply hazardous conditions extending to the surface in certain areas. A responsible remote pilot must assess the full scope of weather hazards, not just those directly at their planned altitude, to ensure the safety of the operation. Professional reasoning. Professionals in remote piloting should adopt a systematic decision-making framework for weather assessment. This framework begins with a thorough pre-flight briefing, utilizing all relevant official aviation weather sources. The pilot should then analyze this information in the context of the specific mission profile, including altitude, duration, and operational area. During the flight, continuous monitoring of weather updates and pilot reports is essential. If conditions deviate from the forecast or become hazardous, the pilot must be prepared to alter the flight plan, divert, or land immediately. This proactive and comprehensive approach to weather information is fundamental to maintaining operational safety and regulatory compliance.